Okay, where did we stop last time? All right. Okay, here is the page we stopped the last time, Shabab. I just solved these basic questions so that we can go through these questions one more time. Now we have the 1 plus cosine of 378. Well, basically 378 is more than the one revolution, right? So we subtract 360. When you subtract the 360, it becomes a cosine of 18 degree. And if you remember the cosine of half angle formula, this is cosine of the 18 divided by 2, which is cosine of 9 degree. You see, 1 plus cosine theta divided by 2 is the cosine of theta divided by 2. So theta is 18. 18 divided by 2 is 9. So we have a negative in front of root, so we have the negative cosine 9 degrees, the correct answer. In this one, again, we have the sine of theta, cosine of theta formula here. Sine of theta, theta is 112.5, cosine of 112.5. So it is the half of sine of 2 theta, right? Sine double angle formula. Sine of 2 theta is, 2 times 112.5 is 125. 225. Well, which is in the third quadrant, of course. And the reference of 225 is 45, and sine function is negative in the third quadrant. So it is negative sine 45, which is negative root 2 over 2, of course. And when you multiply by half, you will get negative root 2 over 4. Okay, these are all basic questions from the previous exam, Shabab. Here is the tangent of alpha over 2. Tangent of alpha over 2 is, of course, remember we have 3 options for tangent of alpha over 2. If you can see on your screen, I can write it another options here, Shabab. Let me see if it is easy to write on the dark side. Remember tangent of alpha over 2. There is another formula. Do you guys remember? Which is easy, actually, easier to remember.
Sine over cosine plus 1.
Yes, sine alpha over. Is this shown on your screen clearly, Shabab?
Yes, very clear.
Okay, so cosine alpha. We could also use this one because they say it is equal to negative 4 over 3. Negative 4 over 3. The first thing I remember, Shabab, this root version, tangent alpha over 2 is positive or negative root of 1 minus cosine alpha divided by 1 plus cosine alpha. So it is equal to negative 4 over 3, as it is given in the question. Now, when you square both sides, right? When you square both sides, you will get 1 minus cosine alpha divided by 1 plus cosine alpha is equal to 16 over 9. Now, why did I choose this formula? You multiply the cross cosine alpha is negative 7 over 25. And and after you calculate the cosine, you can calculate the sine alpha also. It is easy by using the triangle or by using sine square is equal to 1 minus cosine square, root of 1 minus cosine square, of course. So, or just use the triangle, Shabab, you know, when you have the cosine alpha, negative 7 over 25. So 7 is here, 25 is the hypotenuse. So opposite side of the alpha is 24 here. So by the Pythagorean theorem, huh, Shabab? So you can see the sine alpha is also negative. You see? Sine alpha is also negative because alpha, or A, I guess here, A is in the third quadrant. And so since you know the sign of A, so the secant of cosecant is 1 over sine A, right? So which is negative 25 over 24. Again, if you use this formula, Shabab, sine alpha over 1 plus cosine alpha, so you need to use cross multiplication again, just cross multiply. What do you get? Let's say 3 sine alpha, 3 times sine alpha equals negative 4 minus 4 cosine alpha. You see now you have two functions together here. So what you need to do, you need to square both sides so that you can get a connection between sine square and cosine square. And then you can switch from the sine square to cosine square so that you can solve for cosine or you can solve for sine. So, Shabab, solving this equation is a little bit more challenging than solving the, you know, this way. 1 minus cosine alpha divided by 1 plus cosine alpha equals 16 over 9. This is easier to solve for cosine alpha because you have only cosine alpha here. Of course, in the next section, you know, solving trigonometric equations, we will see, you know, how to solve all kind of trigonometric equations. So this is the reason actually I choose this this root formula for tangent alpha over 2. Okay. Okay, Shabab. Now, another nice question is secant of 157.5. So I need to look at cosine, of course. Cosine 157.5 is the half of 315 degree, right? 157.5 is half of 315 degree. That means I need to remember cosine of the half formula, right? Half angle formula, which is negative root 1 plus cosine 315 over 2. Why it is negative, Shabab?
Because 100
57 in the second quadrant. Perfect. Perfect. So Shabab, cosine of 315 is in the fourth quadrant, right? 315 in the fourth quadrant. Cosine is positive, yes, and the reference is 45. So cosine of 315 is equal to cosine of 45. So cosine of 45 is root 2 over 2, Shabab. So 1 plus root 2 over 2. When you simplify this one, you will get negative root of 2 plus root 2 divided by 2. And then for the secant, you need to turn it upside down, which is negative 2 divided by root of 2 plus root 2. Maybe you like to know how to rationalize the denominator. Negative 2 divided by root of 2 plus root 2. So what do we do, Shabab? Do you remember? I should multiply by root, huh?
Yeah, the same value.
2 plus root 2. Right, 2 plus root 2. All right. Then you get negative 2 times root of 2 plus root 2 divided by, so root will cancel, so you'll get inside is 2 plus root 2, right? So are we done yet?
No.
No. I have to multiply another time with 2 minus root 2, huh? All right, which is equal to, Shabab, negative 2 times root 2 plus root 2 multiplied by 2 minus root 2 divided by 2 plus root 2, 2 minus root 2. So result, Shabab?
2?
How did you get 2, Shabab?
2 multiplied by 2 is 4, minus root 2 by root 2, it's 2. So 4
2.
minus 2 is 2.
Exactly. So perfect, Shabab. We got 2 here, which is very nice because we are going to cancel the 2, huh? So cancel the 2 here. So final result is negative root 2 plus root 2 multiplied by 2 minus root 2. This was exam question, of course. So in case they want you to simplify it, Shabab, you know, you need to or could we multiply root of 2 minus root 2, 2 minus root 2? Would that be better? 4 minus 2, it will be root 2. Yeah, we could, let me see, Shabab, why not? We could, why don't we multiply with negative here? Let's see, suppose we have 2 minus root 2, huh, Shabab? Let me cancel this one. So suppose I multiplied with root of 2 minus 2, huh? Now, the inside, imagine inside we have 2 plus root 2, 2 minus root 2. It is 2, right? 4 minus 2 is 2, but we have another root, right, Shabab? So basically, we might get just root 2 only. Root of 2 only. Okay. This looks better, Shabab. This looks better. And now let's multiply. Let's multiply up and down again. So now let's multiply with root 2 only, huh? Shabab, this looks much better. So when you multiply by root 2, you see what's happening, Shabab? So at the denominator, you will get root 2 times root 2 is 2, and the 2 will cancel, right? 2 will cancel with root 2 times root 2, right? So you will get negative root of 2 plus root 2 multiplied by root 2. Now, since both of them are root here, you can multiply in the common root, right? Under the common root, root of 2 times 2 is 4 plus 2 root 2. All right, of course, this is a much better looking result. Right. So if somebody wonders where is it coming from, let me just separate this with a different color. Maybe with this. No. Maybe with blue, I guess. Okay. So I will just show you with the line showing what is happening here. Okay. Okay. Now we have a theta between 5 pi over 2 and 3 pi. And theta prime is the reference angle of theta. then what is sine of theta over 2? Let's remember the formula first, Shabab. Sine of theta over 2 is equal to positive or negative root of 1 minus cosine of theta divided by 2, right? Cosine of theta divided by 2. Now we have theta between 5 pi over 2 and 3 pi. Well, it might be confusing to understand where is the location, Shabab. You know, theta is less than 3 pi, but greater than 5 pi over 2, yani greater than 2 pi actually. So looks like theta is more than one rotation, more than 2 pi. So if I subtract 2 pi from theta, I get the if I subtract 2 pi, Shabab, what do I get? Theta minus 2 pi. What is that?
Terminal.
Coterminal, yes. So theta and theta minus 2 pi are coterminal. So they have the same location. So if I see the theta minus 2 pi, everybody, so that is between the pi and pi over 2.
We make the condition easier, right?
Yeah, we made it easy to see the location, yes. Yes, Shabab, you see, when I subtract 2 pi, 3 pi minus 2 pi is pi, right? And 5 pi over 2 minus 2 pi is pi over 2. So theta minus 2 pi, that means the coterminal is in the second quadrant, right? Less than pi, but greater than pi over 2. If coterminal is in the second quadrant, so the theta is also in the second quadrant. Right. Now, if theta is in the second quadrant, Shabab, cosine of theta is equal to negative of cosine of reference angle, right? Because in the second quadrant, cosine theta should be negative. So negative cosine theta prime, Shabab. Well, now when you substitute into the equation here, you have 1 minus cosine theta. Well, minus cosine theta becomes plus cosine theta prime, right? Because cosine theta is already minus cosine theta prime. So that becomes 1 plus cosine theta prime divided by 2. Now to decide about this positive or negative, Shabab, it just depends on the sine of theta over 2, right? So I have to understand where is the theta over 2, Shabab? Well, theta between 3 pi and 5 pi over 2, when you divide by 2, Shabab, it becomes between 3 pi over 2 and 5 pi over 4. That means it is in the third quadrant. Theta over 2 is in the third quadrant. So sine of theta over 2 should be negative, right? So it is negative root of 1 plus cosine theta prime divided by 2. So the correct answer is C in this case.
So,
Yes.
Doctor,
Yeah.
the sign for the root depend on theta over 2. But the sign for cosine reference depend on the condition that is given.
Yeah, depends on the location of the theta, of course. Theta in the second quadrant. So cosine theta is negative cosine theta prime. Yeah. So there is another negative here. So 1 minus cosine theta becomes 1 plus cosine theta prime. Yeah. Okay, Shabab. Here is the Here is the question that there might be either a misprint or because we have a sine square of x over 2, cosine square of x over 2 is sine x over 2 cosine x over 2 square, and the sine theta cosine theta, as you remember, sine x over 2 cosine x over 2 becomes half times sine x, right, Shabab? And so square will make it 1 over 4 times sine square x. Well, if you change the sine square x to 1 minus cosine square, so you get 1 over 4 minus 1 over 4 cosine square x. So, but there is no square in the question. There is no square here. That's why I put a question mark here. I will check this question again, Shabab, and see if there is anything missing. And we don't see the answer also in the, because they say what is the a times b? A times b should be 1 over negative 1 over 16 actually.
Maybe
so,
Doctor, he used a formula that contains a radical. So square cancel the radical.
I'll check it again, inshallah. So I could not see what is the problem here. I will look at it then, inshallah, and correct it. So the lowering the powers of, you know, trigonometric expressions. So if we have, for example, sine to the fourth x, sine to the fourth power x. That means it is square of the sine square. Square of sine square. Now, if you remember, Shabab, let me write it here again for you to, if you have sine of x, it becomes positive or negative root, right? Positive or negative root 1 minus cosine of 2x, right? This is the half angle formula for sine x. Inside cosine of 2x, as you see. Outside sine of x, yani half of the angle. You understand? If inside cosine x, outside is sine of x over 2, right? So outside is the half of the inside. That's why we call it half angle identity. So the sine of square, sine square will be, you see, Shabab, is equal to 1 minus cosine of 2x divided by 2. You understand? So that is the sine square. But we have to take the square of this one again. 1 minus cosine 2x divided by 2 square. So it's going to be 1 over 4 times 1 square minus 2 cosine 2x plus cosine square of 2x. Right? The square of 1 minus cosine 2x, Shabab. So now let's use the cosine formula, Shabab. If you have cosine of 2x, it is positive or negative root of 1 plus cosine of what? 4x divided by 2. So it is a half-angle formula for cosine. So inside is 4x, but outside is half. Yani half of the 4x is 2x. All right, just like in the sine, you see, inside cosine 2x, outside sine of x, yani half of 2x. So let's see what happens to cosine square of 2x. So it becomes 1 plus cosine of 4x divided by 2, huh? Right? So that's how we got this part here. 1 plus cosine of 4x divided by 2. And you need to multiply by 1 over 4, of course. And at the end, we have 1 over 8 times cosine of 4x minus 1 over 2 times cosine of 2x plus 3 over 8. 3 over 8 is 1 over 4 is here. Everybody, 1 over 4 and plus 1 over 8 is 3 over 8, right? And now this gives you the idea of how to reduce the power, right? How to lower the power of expression. Maybe let me do another one for you. Let's do the second one for you, Sheba. Cosine square x times sine to the 4th power of x. So sine to the 4th power of x times cosine square x. Let's try to remember, this is sine square of x, sine square of x, and cosine square of x. Now, look at this part, Shabab. Do you remember? We have sine x, cosine x square. So it is half times sine of 2x square. You understand? Because sine x times cosine x is half times sine 2x, huh? So you need to take the square, and let's take the continue with sine square x. And also for the sine square x, let's remember, Shabab, just like here, we showed you what is sine square x, huh? Sine square x is here. You see that? So it is 1 plus 1 minus cosine 2x divided by 2, huh, Shabab? So let's continue. 1 minus cosine 2x over 2 times, how about 1 over 2 square is 1 over 4, and sine square of 2x, again, let's go back to here, Shabab. If you have a 2x here, then you are going to get cosine 4x on the other side, right? So you will get 1 minus cosine 4x divided by 2. So you will get 1 minus cosine of 4x divided by 2. All right. So I hope you guys can continue let me write one more step for you. 1 over 4, 1 over 8, 1 over 2, so 1 over 16. 1 over 16 times
1
1
minus cosine.
1 minus
2x.
cosine 2x, yes. And 1 minus cosine 4x. Okay, Shah.
Doctor, can I ask a question, please?
Yes, yes.
Yeah, and the blue one, a half sine 2x all to the power 2.
Yeah.
When I power, it's become what? Sine square 4x? When I square.
Yeah, when you square, half becomes 1 over 4, right?
Yeah, but what about sine?
Sine, it becomes sine square 2x.
So I don't touch 2, right?
لا شباب, this square is the sine square, not the 2x square, شباب.
Okay.
Right? So I recommend you just, guys, you should just look at cosine 4x, cosine to the 4th power x, cosine, power 6x, شباب. So we have 2 sine theta cosine theta, right, Shabab? What was that formula? 2 sine theta cosine theta. It is equal to sine of 2 theta. So 2 times 18 is sine of 36, right, Shabab? This is to make sure that you remember the formulas. Now 2 times tangent 7 divided by 1 minus tangent square 7 is tangent of 2 theta formula, right? Double angle formula for tangent. So 2 times theta, 2 times 7 is 14 degrees. So tangent of 14 degrees. And now we have here 2 sine 3 theta cosine 3 theta. So it is again a double angle for sine. So double of 3 theta is 6 theta, of course, right? Double of 3 theta is 6 theta. And similarly, in the tangent formula, it is a double. So we have 7 theta here. A double of 7 theta is tangent of 14 theta. All right. Now let's remember, Shabab, cosine square of theta minus sine square of theta. What was that? It's a double angle formula of cosine, right?
Yes.
So it is cosine of double of 34. Double of 34 is 68. Or imagine in the exam, if they want to give you a little bit trouble, instead of cosine 68, they can just leave it as sine 22, right? It's a simple exam trick, Shabab, that we should be aware by cofunction, right? So we should not get scared when you see if you don't see the answer, first answer, you don't see that, just don't panic, huh, Shabab? And here we have cosine square of 5 theta minus sine square of 5 theta. Again, this is cosine of the double angle. So double of 5 theta is 10 theta, of course. So it is cosine of 10 theta. And this one is nice looking, interesting, you see. It is just cosine of theta. Because double of theta over 2 is theta, right? Cosine square theta over 2 minus sine square of theta over 2 is cosine of theta. Double of theta over 2 is theta. All right. Now we have a square of cosine theta over 2 sine theta over 2 square. Of course, cosine theta over 2 sine theta over 2 is half of the sine theta. Again, sine of double angle identity, right? Double of theta over 2 is sine theta. Now, when you square it, half will be 1 over 4 times sine square theta. Okay, these are nice practice, and some of them are exam question, of course, most of them. All right, let's remember some tangent formulas. You see, we have tangent theta, sine theta divided by 1 plus cosine theta, right? This one is easy to remember for tangent of theta over 2. You know, tangent of half angle. So half of the 8 is 4, of course. So it's a tangent of 4 degree. Or again, if we like to give you a trouble, right? Maybe we can just read it as cotangent of what?
96.
Right, cotangent of 86. Yeah, in case they wanna, try to confuse you. And 1 minus cosine divided by sine is another option for tangent, right, Shabab? 1 minus cosine divided by sine. It is also tangent of half angle formula, Shabab. So the angle is 4 theta. The half of the 4 theta is 2 theta, of course. All right. So these basic identities, I want you guys to repeat it and look at it again so that you memorize in the exam without, confusing. You should memorize it clearly in the exam, Shabab. Okay. Find the values of sine of x over 2, cosine of x over 2, and tangent of x over 2 by using the half angle formulas. Okay. So we have sine x is given 3 over 5. Then clearly I can calculate cosine x as 4 over 5. We know these calculations, right? By using triangle. So once you know the cosine, then sine of x over 2, right? Sine of x over 2 is positive root 1 minus cosine x, right? 1 minus cosine x, yani 1 minus 4 over 5 divided by 2. That gives you sine of x over 2. And cosine of x over 2 is 1 plus cosine x divided by 2. Cosine x is 4 over 5 again. So it is 1 plus 4 over 5 over 2. And calculation simplifying, I left it to you, Shabab. Tangent of x over 2, how can I calculate? Well, I know the sine x and the cosine x. So with this easy formula, sine x divided by 1 plus cosine x will give you the tangent formula, Shabab. Tangent x over 2. And in this case, we are in a pretty safe area because x is in the first quadrant. X over 2 is also in the first quadrant. So everything is positive. So we don't need to worry about negative or positive problems. In the second one, the x is in the third quadrant. We need to be careful. And x over 2 is in the second quadrant. So sine x is negative and sine of x over 2 is positive, but cosine of x over 2 is negative, Shabab. This is the only difference in the second question. Yeah.
Doctor?
Yeah.
Yes, 4 over 5 inside the radical, it's depend on x, right?
Yeah, it is a cosine of x, right? So you need to look at x. but outside of the radical plus minus, it depends on the x over 2.
Yes.
Right. X over 2. Again, Shabab, we are just trying to, make sure that you guys will just calculate these half angles properly. So this is another example for you guys to practice. And we have a secant is given -3. X is in the second quadrant, as you see. So cosine is 1 over secant, so it is -1 over 3. And then you can calculate the sine x as a positive number, 2 root 2 over 3. You can sketch a triangle, right, Shabab, to calculate the sine x. And also similarly, in the second question, cosine x is 2 over 3 and sine x is root 5 over 3, Shabab. X is in the fourth quadrant, so sine should be negative. Sine x should be negative, not positive, Shabab. Right? Cosine is positive, but sine x should be negative in the fourth quadrant. Now you know sine, cosine, so you can calculate sine of x over 2 because you know the cosine x, right? Okay. Now here is some inverse function applications, Shabab. When you get the tangent inverse of x, so we are going to call it theta, of course. Tangent inverse x is theta. That means tangent of theta is x. So now the question becomes sine of 2 times theta, because 2 times tangent inverse x means 2 times theta. Sine of 2 theta. And now sine of 2 theta is 2 times sine theta cosine theta. So if I know tangent theta is x, and by the triangle I have x's as opposite, one is in the adjacent here. So you can calculate sine and cosine theta from the triangle, Shabab. Because you know tangent of theta is x, so you can find the other functions. So it will be 2 times x over root 1 plus x squared times 1 over root 1 plus x squared. At the end, you will get 2x divided by 1 plus x squared, Shabab. That is the answer. In this case, for example, we will call it cosine of inverse. Let me choose here. Cosine inverse x. We will call it what? Theta, right? Then cosine of theta is equals to x. So the question is sine of half theta, right? Yani sine of theta over 2. Sine of theta over 2 is equal to what? Root 1 minus cosine theta divided by 2, huh, Shiva? Positive or negative, we have to make sure. So which is equal to positive or negative root 1 minus x divided by 2, Shiva. So that's it. We have basically more exercise like this, just calling the cosine inverse x or sine inverse x equals theta, and then just use the formula again to find the expression in terms of x.
Doctor?
Yes.
Where I can find these slides? because in class note it's empty.
It is in the it is in our office time Teams lecture notes, Shabab.
Okay.
So maybe I should show you one more time, Shabab. Let me share the screen. Now, when you come to the office, math office time, math office time, go to the class notebook, Shabab. Everything will be available here. Class notebook.
Yes, doctor, I know, but sometimes when I open a specific chapter, it's empty. There is no solution.
We don't have solution for all of them, but whatever we cover during the lecture, it is there, inshallah. But I will check it one more time. If it is, if there is anything not written, I will fix it, inshallah, Shabab. So you can see all the lecture notes here, Shabab. Okay.
Okay, doctor. Thank you so much.
Ahlan, Shabab. So I'll see you guys next week.
Have a nice weekend.
Inshallah. Thank you.
Have a nice day.
You too,
Thank
Shabab.
you, doctor.
You too.
Have a nice weekend.
You too, Shabab.